Hello, everybody. So this is going to be a a very, very brief video on the conditions we need in order to make a causal claim. Now, before I go into this, I will mention that the idea of being able to pin down causality is and can be and has been and continues to be among some debated. All right. For example, there are a number of scientists in the community that endorse a type of thinking known as dynamical systems thinking, which assumes that many of the phenomena that we may be interested in, especially as behavioral scientists, may be a part of a dynamic system of events in which causality is not unidirectional, but instead may be bidirectional, and pinpointing the causality for these dynamic systems theorists is a lost cause. All right. Now, having said that, because I don't necessarily disagree with the dynamic systems theory perspective. In fact, that system makes a lot of sense, especially when you consider the complexity of human behavior. However, one more thing that, even among us mechanistic thinkers in science, mechanistic meaning we tend to think that we can pin down individual processes that are involved in a sequence of events. Even among us, right, behavioral scientists who are more mechanistic in our thinking, we recognize that any one behavior is multiply determined, meaning there are multiple inputs contributing to a single behavior, and you can't pin down one. All right, you can identify the relative contribution of one by looking at effect sizes, maybe, but ever identifying a sole cause of any one behavior is a moot point. That's not what we do. We look at how multiple things might affect behavior and how those multiple things might interact with one another. That's general mechanistic thinking. So you've got your systems theory, which says there are no causal components. Everything's in one big system. That system may even look very chaotic, but if you look at the patterns over time, patterns emerge, and you can start looking at relationships. Mechanistic thinkers, on the other hand, argue that yes, you can identify causal direction, but even among us mechanistic thinkers, we would not suggest that bidirectionality, meaning one IV could affect DV and that DV could then affect the IV. We're not going to say that kind of thing can't happen. In fact, for mechanistic thinkers, those who use your standard experiments like the ones we're learning about in this class, one argument that I endorse is that every study is a snapshot, all right, of a sequence of events. It's a snapshot. It's like taking a Polaroid, all right, or taking a quick video or a quick picture with your phone. You're seeing a freeze frame of a admittedly complex system, all right, and we can attribute, at least I would argue, we can attribute the causal relationships in that moment. You take another snapshot of a similar situation, you should get the same pattern of interactions. That's replication. That's establishing external validity. But if you take another snapshot of a different part of the system, you might get different causal arrows. You might get the outcome variable in your prior study showing an effect on your predictor variable in your prior study. So it can get very convoluted and can get very confusing. So if all of that seems to be a little confusing, a little daunting, you can set it aside. Just know that there are folks who endorse systems thinking or dynamic systems thinking that would argue that the three things that I'm about to tell you that are used for establishing causality are pointless, all right? But the majority of scientists are mechanistic thinkers, like me. And so the majority of us, and you can tell this by the majority of research methods books, employing this mechanistic thinking and talking about these three factors needed to make a causal statement. So if all of that was confusing, you can throw it out. I just want you to know that systems thinkers don't endorse or may not necessarily endorse these three factors or these three elements. Now, What are the three elements we need to make a causal statement? First, we need something called temporal precedence, all right? Meaning our causal agent, our variable that we are saying is having an effect, all right? That has to come before our dependent variable. So our predictor must come before our outcome variable, all right? Our IV must come before our DV in time, okay? So if you measured your dependent variable and then manipulated your IV, you don't have temporal precedence, okay? Your IV has to be manipulated before your DV. It has to come in time before your DV. That's temporal precedence. So that's the first thing you need to establish to make a causal claim. The second thing is you need covariation. Now, for those of you for whom the mantra correlation doesn't equal causation has been beaten into your head, that might feel a little weird because covariation is unstandardized, statistically speaking, unstandardized correlation. So yes, if all you have is evidence of correlation, no, you don't have evidence of causation. But you do need correlation. You need evidence of correlation. You need evidence of covariation before you can make a causal statement. You need other things, temporal precedence and the third element, which we'll talk about in a little bit. But you do need evidence of correlation before you can make a causal statement. Now, why is that? Well, if your IV is causing changes in your DV, the two are going to be correlated. All right, let's say that I'm manipulating rejection and I'm measuring self-esteem, right? Okay, and that's been done many times in prior research. But if I want to say that when a person is rejected, their self-esteem suffers, if I want to say that, then I manipulate self-esteem. So I have maybe a positive self-esteem condition and a neutral self-esteem condition. And then I measure people's self-esteem after they do one of these two conditions. So some people, I randomly assign some people to have their self-esteem bolstered, and I randomly assign other people to have nothing done to their self-esteem. Maybe they write about the weather, something completely unrelated to self-esteem. And then people in both conditions, I measure their self-esteem. Now, if that rejection is causing a change in self-esteem, then there's going to be a relationship. There's going to be a correlation between which condition they were in and how high their self-esteem was on that final self-esteem measure. All right. So let's say we coded everybody in our control condition as 0 and everybody in our rejection or not rejection condition. I keep going back and forth between different studies, don't I? All right, let's clear this up. Let's say we look at rejection on self-esteem. All right, so we got a control condition where they're not rejected. And then we got an experimental condition where they are rejected. All right, let's stick with that. Control condition, no rejection. Experimental condition, they're being rejected. And then we measure their self-esteem. All right, we would expect, right, that people in the rejected condition would have lower self-esteem. Sure, right? Well, in order to make the causal claim that rejection is reducing self-esteem, first, we've got to have that first element, temporal precedence, right? That manipulation of rejection has to come before our self-esteem measure. If that self-esteem measure is before the rejection manipulation, there's no possible way for the rejection condition to have an effect on something that came before it. All right. So our measure of self-esteem has to come after our manipulation of self-esteem. And then there's a second factor of covariation. Your IV and your DV, your predictor and your outcome must covary. They must be correlated if your IV or your predictor actually does affect your outcome variable. All right. So let's say we code our control condition as 0. Our experimental rejection condition is 1. If rejection is causing an effect in self-esteem, then we would expect a negative correlation such that as we move from 0 to 1 in rejection, meaning as we move from our control condition to our rejection condition, self-esteem should go down. right? That's a negative correlation. So as we go to higher values in the rejection condition, meaning go from control to our experimental rejection, which we coded as 1, control we coded as 0. So as we move from 0 to 1, self-esteem scores should go down, right? So if we did the Rosenberg self-esteem scale, when it's coded the way it's traditionally coded, it scale, I think the scores range from 10 to 40. So we would see the values in each of those groups go down. So there'd be a negative correlation. All right. So there we go. 2 values, right? Or 2 conditions: temporal precedence, covariation, which is just an unstandardized correlation. All right. So if you have evidence of causation, you know they're correlated, because correlation is a prerequisite of making a causal statement. It's not enough, it's not sufficient, but it is necessary. Okay, so temporal precedence and covariation. And the third one is no alternative explanations. So we want to say that rejection, sticking with our example, the one that I finally said, sorry guys, we want to say that rejection is causing a drop in self-esteem, right? So we've manipulated control versus some people, nothing happens to them. Some people are always included, some people are rejected, and then we measure their self-esteem. Well, we have to rule out any other alternative explanations for why people in the rejection condition might have lower self-esteem. All right. Well, there's all number of individual difference or subject variables, we might say. You might say, well, maybe the people who had low self-esteem in the first place were all in the experimental condition. Possibly. But if we use methods of experimental control like balancing, right? Like random assignment is probably the biggest and most used method of balancing used in science, right? Well, if we did that, if we randomly assigned people to condition, then there should be an equal number of low self-esteem people in both conditions. So that confound, that which is a subject variable, goes away. Because if random assignment worked, and it doesn't always, but usually it does, and certainly if we replicate, it will work over time. If we've randomly assigned, then we've balanced out that pre-existing subject variable. And so the alternative explanation of, well, maybe they already had low self-esteem, it doesn't work anymore. Not if we've randomly assigned and we still find a difference. All right, and that goes for any subject variable or any, which is also known as an individual difference. So anything that could threaten our internal validity threatens our ability to make a causal statement, all right, because of that last piece, all right? So anything that could be a legitimate, reasonable, alternative explanation for the difference between our conditions on our DV could be an alternative explanation and threatens our ability to make a causal statement. All right, so there are your 3 elements: temporal precedence, covariation, which is unstandardized correlation, the statistic for it is anyway, and no alternative explanations. Those are the 3 elements that you need to make a causal statement. And if anything threatens any of them, your ability to make a causal statement falters. All right, guys, that's it for this video on the 3 elements you need to make a causal argument. As always, if you have any questions, send them my way. If not, have a great week, month, however long until I see you again, and I will see you later.